Hi, in this next video we're going to work with operations with functions. Relative to the previous few sections, this will be a lot less involved than the previous ones. But especially when we get to composite functions, we want to make sure we have that part down. Most students, especially the honors level, have seen this before and have done this particular part before, but composites are always a bit of an issue. So let's take care of the first addition, subtraction, multiply, divide part. I'll use this for all of my examples for this particular lesson. So I'll let this be f of x and this be g of x. So whenever I refer to f of x, I'm going to use this, and I'll put it, and then whenever I use g, I'll use that. So first, I'm going to add them up. And notice I'm not putting a number in, I'm just going to add the functions together. So in this part, I take whatever f of x is, which is x squared 2x minus 1, and I add in x minus 2. Now you'll notice I'm using quantities around it. That's to avoid sign errors, and it's just a quality idea to use, especially when this is a minus sign, as distribution will occur. So at x squared 2x minus 1 and then plus x minus 2, combine your like terms, and that's it. So f plus g of x, which is another way to write these two mean the same thing, to write that addition problem, is equal to x squared 3x minus 3. When I combine all my like terms, 3x minus 3. And that would be your final result. And that's it. And of course for addition, if I turned it around, I would get the same answer. That's not the case for subtraction because of the distribution of the negative. Here, this first, whatever one's first is first. So f of x would be the same as it was before, x squared, 2x minus 1, then a minus sign, and then the g of x, which is x minus 2. And you can see that if I flip this around, it would change it actually. It wouldn't be exactly the same, not like this. This is what we call commutative, and this is not. So we would have x squared plus 2x minus 1, and then minus x and plus 2, distributing out the negative sign. That's a plus 2 there. And then we combine our like terms, and we would have f minus g of x is equal to x squared plus x plus 1. And that's it for adding and subtracting. Okay, multiplying. We'll use the same functions. And there's not a lot of examples in this section, so I made my own problems up for this. Let's do with f of x times g of x. And now here's where the confusion for students come along. This symbol right here, if we use an open circle without it colored in, that's called a composite function. When it's colored in, it's a multiplication, as it always has been. So we're simply going to be multiplying f of x times g of x. And that gives me 3 terms times 2 terms, which is 6 terms altogether. So we'll multiply this out. I'll multiply this times all 3. And you could do it that way too. It doesn't matter how you go about doing it. That'll give me x to the third, and then plus 2x squared minus x when I multiply x times each of those. Now I'm going to multiply the negative 2 times each term as well, and that gives me the 6 multiplication problems required. Minus 2x squared, and then minus 2x squared, and then negative 4x, and then positive 2. All your like terms, and all I did was stack my answers. I could write them straight out like a string of answers. It's up to you how you chose to do this when we first were learning how to do this a few months ago. X to the third, And then this becomes 0x to the second minus 5x plus 2. And you'll notice the answer is in standard form with the highest exponent first. And this would be f times g, f of x times g of x equals. And this part, colored in, means that it's multiplication. For division, you wouldn't be able to do much, actually. You would just put one on top and one on bottom in the fraction. Now, if we could factor this, then we might be able to what we call remove the discontinuity. But this is not factorable. There are no numbers that make 1 and subtract to equal 2. So if we were dividing it, it would simply stay as a division problem, and then you can plug values in if they were given along the way. Okay, now for the composite part, because the division, there's not much to do. Actually, you would just write it one on top and one on bottom, and that would be the end of it. Composite functions. Let's say I have f o g of x. Notice that this is open circle. That means a composite function. What we're doing is f of g of x. These two mean the same thing. It means take the function, the first function, and instead of putting in the variable, you put the entire function g in the place of where the variables were. So, for instance, I'm going to start out with f, that's this function, but instead of writing the variable down, I'm going to leave space. And in that space goes g. So in that space would be x minus 2. And in that space would be x minus 2. And then we simplify from here. That'll be requiring to square this out, to square it, x squared, and then multiply together and double, and square. Distribute, and then minus 1. Okay, combine your like terms. I start out with the highest power, which is x squared. There are no others. And then the x's, that'll give me negative 2x. And then the integers, 4 minus 4 is 0, and then minus 1 is negative 1. And x squared minus 2x plus 1, almost the same thing. It's actually not exactly the same, obviously, because we were plugging one into the other. Well, fumble. All right. Now, let's plug in some values and use numbers, because we can actually do some calculations also. G of f of, let's go with 2, which is the same as this is called a composite. The word composite means there's more than one item, more than one thing that makes it up. Composite numbers have more than one set of factors. Composite means more parts, several parts together. So we call this a composite function. It's two functions put together. So if we're doing this, we're going to start out with the function g. So we start out with the function g, but in place of the g, we leave open, and we're going to plug in, and then minus 2. So I took the function g, which is x minus 2, but in place of the x, I'm going to put the f function, x squared 2x minus 1. This is g of f of x, is how that's read. G of f of x. So simplify, and I would have x squared plus 2x, and then minus 1 and minus 2 is minus 3, is g of f of x. And of course, we have a number 2, so we're going to replace now 2. So in place of the variable, this time we're going to plug a number in. And that'll be g of f of 2, open circle. And this time I'll plug in the number 2, the number 2, and then do some basic calculations. 2 to the second is 4, plus 4 minus 3, which is 8 minus 3, 5. So this would equal 5. And that's basically how it's done, composite functions. We'll do more when I see you guys at Google Meet. Thanks.